Hello everyone, today I am going to talk about our team project on handwritten digit recognition. The project focuses on classifying the digits from 0 to 9 using various machine learning algorithms. The main goal is compare the performance of these algorithms and identify the most effective one. For this project, we use MNIST dataset which contain 17,000 grayscale images of handwritten digit. Out of these, 60k images are used for training and 10k digits used for testing. Each image is 28 by 28 pixel in size. In our project, we implemented 6 different algorithms and compared their accuracy to determine the most suitable one for digit classification.
Hello everyone, in this project I implemented k-nearest neighbors classifier from scratch to recognize handwritten digits using a dataset similar to MNIST. After normalizing the data and visualizing some samples, I implemented the Euclidean distance and KNN logic. I tested different k values and found the best performance at k equal to 5. Training on 10,000 samples, the model achieved 86.53% accuracy on the full test set. I also evaluated it using class-wise accuracy ROC curves and confusion matrix to better understand its performance.
In this part, we are classifying handwritten digit using naive Bayes and PCA. Firstly, PCA reduces the image size by keeping important features and removing noise. Then we calculate the prior probability of each digit and the likelihood using the Gaussian formula. Finally, we multiply them to get the probability for each class and predict the digit with the highest value. We can see the confusion matrix and overall accuracy achieved in this model is 88.15%.
This is how logistic regression work for classifying digit. First, the model calculates a score for each class by multiplying the input with weight and adding a bias. Then it uses softmax function to turn those scores into probabilities, so we know how likely the input belong to each class. And finally, it picks the class with highest probability as the prediction. So basically, by using logistic regression algorithm, I'm getting accuracy of 92.57%.
In handwritten digit classification, using decision tree, we calculate information gain for each pixel at every step. The pixel with highest information gain is used to split the data. This process repeats to build the tree. After training, the tree follows these steps to predict the digit in a new images. The decision tree classifier achieved an accuracy of 86.32 on the dataset.
In this project, I implemented random forest classifier to recognize the handwritten digit using datasets similar to MNIST. After normalizing the data and visualizing some samples, I trained the model using ensemble of decision trees to improve generalization and reduce overfitting. I experimented with a different number of tree and depth setting and formed well-balanced configuration. Training 10k samples, the model achieved 90.25 accuracy on full test set. I also evaluated using class-wise accuracy, ROC curve and confusion metric to better understand its performance.
So in SGD-based linear SVM model, we use a 1 versus all setup, training a separate binary SVM for each of the digit. The model uses mini batch SGD with hinge loss and L2 regularization. During training, weights are updated only when the margin condition is violated. This process repeats across multiple iterations, and during prediction, we compute scores from all the classifiers and select the digit with the highest score. To handle non-linear patterns, we apply a random Fourier features to approximate the RBF kernel. Instead of computing a large kernel matrix, we project the input data using the cosine-based random mappings. This transformation lets us use a linear SVM in a non-linear space. The same SGD-based classifier is trained on the transformed data, enabling efficient and scalable non-linear classification. Comparing, the RRF model performs better than the SGD model with achieving an overall accuracy of 95%.
And this slide gives an overall idea of how well each algorithm perform in terms of accuracy. So here is demo. Basically, when a digit tree is drawn on the canvas, the model processes that drawing and gives us 3 as the predicted result. And that's all from our side.